Hey, good morning, guys. Hope everybody had a nice weekend, enjoyed their Mother's Day, spent with their families. Uh, Thanks for printing out those notes the other day, and hopefully you had some time to look over them. Hopefully you're utilizing the day fives because those days are designed for you to catch up with any assignments. Identify things that you might have questions with, and get those things addressed. So hopefully you're doing that. And then hopefully you're also spending some time just kind of concentrating on yourself and trying to find some ways to have some fun during this time. Anyway, we're moving on to chapter 12. It's a lot of similar stuff as we've been doing. However, in this particular chapter, I don't know if I said chapter 12, it's chapter 10. In this particular chapter, what we're doing is we're comparing two samples, right? So the past few chapters, we've looked at one proportion or one mean, just from one sample. Well, now we're going to take two populations or two groups, and we're going to compare the population of the first to the population of the second, and we're going to see if there's a difference. Okay, that's the whole idea. Is there a difference in the two proportions, which we'll focus on today, and then we'll look, is there a difference in the means? And the way in which we're going to identify these differences is through confidence intervals and significance tests. All right, so we'll take it slow. Today we're just going to work on proportions, all right, with confidence intervals. So in our notes, if you follow along with me, here's two guys, Nate and Kyle. They work for the DMV. They live in different states. In Nathan's state, 80% of the registered cars made by Americans are made by American manufacturers. In Kyle's state, only 60% are. So they both select a sample. Nathan selects a sample of 100. Kyle selects a sample of 70. And we're going to let the proportion of N minus the proportion of K be the difference in the sample proportion of cars made by American manufacturers. Okay, so what is the shape of the sampling distribution? All right, well, what do we know about some of the conditions that we've checked? Well, we know that this condition, large counts, allows us to say that if it's satisfied, we can assume that it's approximately normal. That is, if we take our sample size and multiply it by the percentage of American manufactured cars. The same thing if we did our sample size minus or times 1 minus that 0.8. So if we just look at 80, 20, and we do the same thing for Kyle's state, and we get 42, and we get 28, if all these numbers here satisfy our large counts condition, it is said to be approximately normal. Okay? Find the mean of the sampling distribution. Well, what the mean would just be the difference of Nathan's state minus Kyle's state, right? That makes sense. The average difference in the two proportions of American-made cars in both Nathan and Kyle's state. So just 0.8 minus 0.6. And finally, the shape. I'm sorry, not the shape of a sampling distribution. It would be the spread of it. All right. So we got the shape, the mean, and then the spread. The spread would be the standard deviation, and we would just follow our formula that we followed in the past, and it would just be n times 1 minus n, and n times 1 minus. Sorry, not n. It should be p, our proportion, not n. Sorry. So p times 1 minus p divided by our sample size, which is n. And the same thing over here with the other proportion. Again, it would just be p times 1 minus p and it would be the square root of whatever we would get there, right? All this is underneath the radical, and that gives us our spread or our standard deviation. Okay, so for confidence intervals, we kind of know a lot of this stuff. We're told in this example here that many news organizations conduct polls. This one was done during President Obama's second term. So this was done to see his approval rating in October of 2012 compared to his approval rating in October of 2013. So the Gallup poll asked 1,500 randomly selected U.S. adults Do they approve? And it was 52% compared to 46% a year later. So we're asked a couple things here. Calculate the standard error, use the results to interpret the 90% confidence interval. And then, so I really want us to focus on parts B and C. All right. This first part here was kind of what I just did in the last problem. Right. And you can kind of read that yourself as you go through the notes. All right. So for us to make this confidence interval, we have to continue checking the conditions. First, we want to state the parameters of interest. We want to define how we're going to label these. For instance, like P sub 13, that means it's the proportion of U.S. adults who approved Obama's job performance in October of 2013. P sub 12 would be those adults that approved it in October of 2012. So we have to designate the difference that we want to make. We have to define which one we want to look at as the first proportion minus the second proportion. That's important. The conditions should seem very familiar to us. We need to make sure that the data comes from random samples. We need to make sure the 10% condition is satisfied. And like I spoke about a few minutes ago, we have to make sure the large count is satisfied because that allows us to say that it's approximately normal. So remember, it's N times P and N times 1 minus P. You have to do it for both. You have to do it for those that were polled in 2012 and those that were polled in 2013. Once you do that, you're going to get your confidence interval. You can write it like an interval like this. This is good. Now, if you had went the other way, meaning if you had first did 2012 minus 2013, you would get similar numbers. They would just kind of be in the opposite order and they could be positive, okay? But it's very important that you just define the order of which you are using this. And I'll kind of speak to that in a few more minutes. But once we get our interval, we can come up with a conclusion. We're 90% confident the interval from negative 0.09 to negative 0.03 captures the true change in proportion of U.S. adults who approve of President Obama's job performance from October of 2012 to that of 2013. All right, so we definitely have to write that sentence as our concluding sentence. And then finally, a question that I like here. It says, based on your interval, is there convincing evidence that his job approval changed? Is there convincing evidence? And there is convincing evidence. And the reason for that is because if we simply looked at our interval, 0 is not contained in there. 0 signifies no difference. It was the same. So if 0 was in our interval, we would say that, well, there's a chance that, it stayed the same. So because 0 is not in the interval, we do have concluding evidence that it did in fact change. All right, on page 3 in your notes, you should see this, check your understanding. All right, now rather than me write it out for you, just because that can be pretty time consuming, I have it done right here. So just follow along in those notes. You're going to hopefully transfer this onto some paper, okay? But the first thing, like I was saying, you have to define how you're going to identify the proportions. So I just put P sub 1. We'll say that those are the true proportion of teens who go online every day. And P sub 2 will be the true proportion of adults who go online every day. Both came from independent random samples. We sampled 799 teens, and that's less than 10% of all teenagers. And we sampled 2,253 adults, which is certainly less than 10% of all adults. Again, I'm getting this from the data here. Okay. The next part, large counts. We have to identify our sample size, which for teenagers was 799. And we have to identify what our proportion is, the proportion of successes, those that do go online every day. And that would be 0.63. We would have to do the same thing for adults. Our sample would be 2,253. And those that go online every day would be 68%. All right. For large counts, we're about to do N times P. All right. That's kind of what I did here, right? This is my N times P. and n times 1 minus p. And the same thing was done over here, and we were able to get these numbers. These numbers, all being greater than 10, shows us that our large counts condition is satisfied. So guys, as you are watching this, taking notes, not only look at that example, but it was done for you twice earlier. That same thing is done here in the Obama example, and that same thing was done up here when we checked in Nathan and Kyle's example, when we checked to see if the large counts condition was satisfied. Okay. Once that works, now we have to do what's called a 2-proportion Z interval. So a 2-prop Z interval, we're going to hit menu, statistics, confidence intervals, 2-prop Z interval. Two meaning 2 proportions. All right, we have 2 different samples, and they're both proportions that we're using. All right, this is important. So our first will be our teenagers. The 700. Sorry, that's not the correct number. That's our sample size. 709. The correct number that should go here, I believe, was 503. I'll show you where I'm getting these in a second. Right here, it should be the 1,532 out of the 2,253. Now, I got those numbers simply just from our large counts, right? The successes and our sample size. In this problem, I believe we were asked for a 90% confidence interval. So we got to change this. 0.90. And we hit OK. Yeah, 0.90. Now, let me just make sure. I had a little typo here, guys. I got to go back and fix that. Look, I put 709, so I'm going to do that again. All right, so it's menu 666. All right, so menu 666, easy to remember. Successes, 503. 799. This number was 1532, and this number was 2253, and it should be a 90%. All right, there's our answer. So negative 0.0828 to negative 0.018. All right, that's our interval. Let me go back to my answer here. You can see that I wrote down the interval, and then I gave a concluding sentence. All right, so we are 90% confident the interval from captures the true difference in the proportion of U.S. adults and teens who go online every day. So the difference between teenagers and adults is somewhere between these 2 percentages. Okay. I would like you to watch this video today, take the notes, and then once you're done watching this video, you're going to answer a similar type of question. All right, that question will be on a Google Doc. And look what I did. I put state the parameters of interest. So you can define what your first proportion and second proportion are, check your conditions, you can give your interval, and then ultimately write your conclusion. All right. So guys, let me know if you have any questions. All right, try to do this one problem today, submit that, and we'll go from there. All right, thanks guys. Enjoy your day.